Okay, so in the example two, we're going to actually redesign the same chain system, but we're going to have a smaller drive. Okay, so it's exactly the same RPM, the same power, but we're going to use more than one strand. So we're going to do that simply by applying what we learned from the slide earlier. We're going to use a multi-strand design to permit for the smaller pitch chain to be used to transmit the same design power of 21 horsepower and the same speed of 900 RPM. So you remember that from the above slide and also from the book, if you go to the page 281 in the chapter 7 of the textbook, you'll find that the ratings are for the single strand of the chain, although the multiple strand do increase the power capacity. They do not provide direct a multiple of the single strand capacity. So once again, we said that the single strand is not half or double, and it's not one third of the treble, and it's not 1/4 of the quadruple. So maybe we're going to have the strand factor to be 1.7, 2.5, and 3.3. So in this scenario, we're going to choose four strands. So that's mean that our power here, or 21 horsepower, is going to be divided by 3.3. So each strand out of the four is going to have the power to be equal to 21 divided by 3.3, which is going to make it 6.36. Now, if I get to go back to the chain type number 60, you will find that actually these chains doesn't have the low range of the power of 6.36 with the 900 RPM. So let's try a smaller chain. And in that case, we're going to go to the type 40, table 714. The number 40 chain have a half inches pitch value with 72 sprocket will be satisfactory. And we did that simply by finding the 900 is here, the 6.57 horsepower, and thus will tell me that the number of the teeth is going to be anything between the 16 or 17. We're going to choose 17. Okay, because the horsepower we have is 636, so the 618 cannot take it, so the 657 will take it. So we're going to choose 17 teeth for the smaller sprockets. We will say, okay, now we choose 17 earlier or 18. It wasn't that difference to get the diameter. Now you will see that actually it's going to be different, mainly because the pitch value has been dropped down by 30%. It was 0.75, now it's 0.5 millimeter, 0.5 inches. Okay, so once again, it's from, if you would like to check it on your ruler, it's from the 19 millimeters drop down to 13 millimeters. So this will make a big difference depending on the length we are going to have. Okay, so the 17 is going to be used, and once again, we go back to the tables here. The 40 is going to have half inches, 3,700 pounds for the strength, and for the case of the metric, we have the 0.8, sorry, 0.8b, which is going to have 12.7 and 17.8 kilonewton for the braking strength. So number for the chain is going to be used. We can now calculate the output number of the teeth. The Veals ratio, remember, is the same, 3.83. We haven't changed the output for the RPM. So now we're going to multiply the 17th by the 3.38, and the number of the teeth is going to be 65.11. We're going to use 65 teeth. Again, we're going to calculate the actual expected output speed. 17, 65, so 65 divided by 17 is going to be the new VR ratio. Okay, and it's going to be 3.8235. So now we would like to check if the output RPM is going to be within the range of 24 something or not. So we just did do that, 93.23 radian per second, multiplied by 7 divided by 65. It's going to be 24.38, so it's going to be okay, 232. It's within the average, so we will accept this design. Now we know the number of the teeth, and we can calculate and we know the pitch value is 12.7 millimeters, so we can calculate the new diameters. So the diameter 1 is 12.7 divided by the sine of 180 divided by 17. And for the diameter 2 is going to be the 12.7 divided by the sine of 180 divided by 65. Okay, so this will be the equation we're going to apply, and we're going to get that the first one is going to be 69.16. Remember, it was 109. So we almost have something like 45%, okay, within the range. Okay, sorry, 55%. And the same thing is going to be happening here. We're going to have 262. It was 400. So you can see that by changing the pitch value, the diameters will be changed a lot. So that's how we're going to do it. Just choose a different chain, divide the power by the factor of the strand, and you will get a smaller sprockets. Now, we need to find the C value. Again, we're going to get something within the range. Let's choose 30 now. I'm going to use 30 because we can actually check 30, 35, it's up to you. If you're going to put that in Excel sheet, everything will be done within seconds. Now, we're going to calculate the L value for the chain, okay, by applying the equation 718. So the L value is going to be equal to, sorry, I should, where's my equation? It's here. Yep. So we're going to get that the value of the pitch is going to be 102.9, so which is equal to 51.45. I'm going to choose 103. Again, I changing that from the book, they choose 104. I use 103 pitches because I would like to have a shorter chain as well. So we're looking at the range of 51.5 inches is the length of the chain we're going to have. That's the open chain, of course. Now we're going to use the L value and the N values to calculate the actual C value. Okay, and we're going to come out with the value to be 30.289. So it's 30, the one that we're looking for. So the C distance is going to be equal to 15 inches or 381.36 millimeters. Use the 30 pitches, and this guess was very good. Now that's it. We're only going to calculate the thetas, okay, with the new diameters, and you see that has been confirmed. The theta 1 should be more than 120. Okay, and we'll get that 151, which is more than 120, so it should be okay. And continue with the second one, again to have 208. Double check that the theta 1 should be equal, plus theta 2 should be equal to 360. And then my summary design is going to be the chain number 40, half inches pitch value. The fourth strand has been used. 103 pitches has been used for the length, 52 inches in total. And you can change that to millimeters, of course. The sprocket, the same thing, is going to be the number 40 chain for the four strands, half inch pitches inch. And the small sprocket is going to have 17 teeth with 2.71 2.721 inches diameters. The large one is going to have 65 teeth with the diameter of 10.349 inches. The maximum center distance is 15.27. No, for us is 15. And the type B lubrication oil path is going to be used. So just remember, for us it's 15. We change this value. And thus, if I'm going to sketch the two system next to each other, you can see actually that we have been dropped the length, the distance, center to center distance from 726 to 387. It's almost half. Okay, and the same thing happening with the diameters. Actually, you should have the degrees. Yeah, that's the same angles, and the length has been dropped. So just imagine for 100, we drop it down to 69. The 400, we drop it down to 262. The center to center distance from 726, we drop it down to 387. The contact area for the larger sprocket is longer, and it's going to be a little bit less for the smaller one. Okay, so that's for the difference between the four strand and the single strand. Now we still have another two examples going to be done on a separated videos.